Hello and welcome to Lean Six Sigma Green Belt Certification Lecture 2. So in this lecture, we will have an introduction to Lean and Six Sigma. So let's quickly see what is included in this particular module. So we're going to talk about what is Six Sigma, and we also try and see how graphically we can represent Six Sigma and a few examples of Six Sigma process. We'll talk about some benefits expected out of Six Sigma implementation. Then as a methodology, we will try and define Lean separately. And we'll also see the applications of Lean Six Sigma. And finally, talk about how we can calculate cost of poor quality to create a baseline for your project even before you kickstart your Lean Six Sigma journey. Okay, so these are the contents. So let me quickly walk you through what Six Sigma. Right? Six Sigma is a methodology. It's not a tool. It is a methodology which will help you to solve business problems, or it can help you in designing or redesigning a particular business process. So the applications are in two different areas. When there is an existing process, and if you have a problem in that process, if you want to solve it, you can use Six Sigma. And the methodology, what we generally use there is the DMAC methodology, which talks about define, measure, analyze, improve, and control, right? And it is all about reducing the variation. We will talk about variation in a bit, and you will be able to appreciate it better when we talk about it in the upcoming slides, okay? So it's about variation reduction and improving the process effectiveness. And whereas in the case of DFSs, or if it is to do with design or redesigning an existing process, when there is an existing process and if you want to enhance the performance by redesigning it, is called as redesigning that process. Or if there is no process at all, we are defining a process, a new process, and when we are defining it or designing it, we are ensuring that the process will be capable of operating at Six Sigma levels, right? So that's called as a design process project or a redesign project. We call it as design for Six Sigma. Two methodologies comes handy there. It's a DMA DV method or a DMA ODV method, not very different, but it is called as define, measure, analyze, design, and validate, okay? So when it comes to redesign and designing, we use Six Sigma in a DMA DV or DMA DOV. In generic terms, we call it as design for Six Sigma projects, or when it comes to problem solving, we generally use DMAC. So in this certification program, we're going to talk more about DMAC, okay, as a methodology. And Jack Welch, who is responsible for institutionalizing Six Sigma in General Electric, and from there, a lot of companies started adopting that. As per him, this is a methodology used to enhance your customer experience, reduce cost, and obviously to make good leaders for tomorrow who understand the business, the criticality of the customer-centric decision making and process designs, and make good leaders for tomorrow. Okay, so that's in a nutshell how we define Six Sigma. Okay, so six we understand, but we're still confused of what is that word Sigma. Okay, so let me help you there. So Sigma is nothing but in Greek, it's a Greek word, and the meaning of that word is standard deviation. Okay, so now we understand that standard deviation is a measure of variation or deviation, right? So it gives us somewhat a clue that, okay, so we are talking about six standard deviations, so it has got something to do with reducing the variation, being more consistent, right? So we will try and understand the significance of that number six in the upcoming slides. But as a methodology, it's about six standard deviation, and it's probably something aiming at reducing the number of standard deviations, or reducing the standard deviation, not the number of standard deviations, and reducing the spread of the process. Let's figure that out in the next slide. So even before we jump on to what is Six Sigma, let's try and understand sigma, standard deviation, what's the real meaning of it and how do you calculate it? So you have these observations. Let's say that, this is the variable waiting time in a hotel to get, or in a restaurant to get your takeaway. Okay. So you have some people waiting for 10 minutes and we have got some people waiting for 40 minutes. And 7 people, we've taken the readings of 7 people. Let's assume that. And we see that the average wait time is about 25 minutes, right? But this is not a complete measure of the entire data set. So obviously this is the middle point, right? Or the mid value, we call it, or some sort of a middle representation of this entire data set. But it'll be always good if we can talk a little in terms of the variation also. Not that all customers would wait for 25 minutes, right? Some customers wait for 10 minutes, some customers wait for 40 minutes. It depends on the type of food you order perhaps, right? So if I have to take an average deviation from this expected mean time to the actual time, so if I take the deviation and take the average of those deviations, that's nothing but standard deviation for me. But it's easier said than done because I've got values more than 25 and less than 25 as well, more than 25 and less than 25. So when I subtract 25 from this, I will get a positive number, but when I start subtracting 25 from these numbers, I'll get a negative numbers. So negatives and positive gets cancelled out, and when I try to calculate the average, that average will become 0 again, right? To avoid that, we use this formula, very, very handy. That means I'm going to individually find out the deviation between 25 and each and every point, that is x bar minus xi. And then I've got a summation here, right? So I calculate the difference, and then to avoid that problem with 0, I square it, because when I square it, negatives will become positives and positive will remain as positive. So I can easily add it up. It will not result in 0. And then finally divided with the number of terms I have. So, but here it's a small catch, instead of applying n directly, we put n minus 1. This is called as degrees of freedom. We will try and understand it a little later. But for now, understand that, if the samples are less than 30, we generally use n minus 1. If the samples are, in this case, it's only 7. So this is a smaller sample size. So we generally use n minus 1. If that sample size is more than 30, we generally use n. Okay. So for now, just understand like that. So I calculate the squared distance between this divided by my standard deviation and take the square root. Square root is nothing but to bring this value to the original value because we squared it, right? So now we have to get it back to the original value. So we take a square root of it, and that's how we calculate this, right? So each value is subtracted from 25, square it, divided by 7 minus 1, and take the square root of it. So 10.8. So on an average, the deviation in this data set from the mean is about 10.8 minutes. So it's lower the better. If I have got lower standard deviation, my process is leaner and it is actually operating closer to my target or probably to my mean, right? So that's my intent of driving Six Sigma, to reduce this standard deviation so that I have a leaner process which has lesser number of defects and operating always closer to the target. And that's the methodology, okay? So now let's look at how we can graphically represent this Six Sigma concept, okay? So that's very simple. Let's quickly look at that, okay? So here is my process, and this is the curve which represents the behavior of my process. So it's a normal distribution, and the area under this curve, right? If I add up all these area under this blue line, right from here to here, that will be 100%, right? So the maximum of the area is 100%. So if I can fit 6 standard deviations in our previous example, if you remember, the standard deviation was 10.08. So let's assume in this case, if we are able to fit 6 times of 10.8 between my mean value and some specification limit given by the customer. So specification limits are designed by the customer, given by the customer. That means this is the highest point where you can go, and this is the lowest point where you can go. If it is lower than the lowest, that LSL, we call it as a defect. If it is higher than the USL, that we call it as a defect as well, right? So between the mean and the USL, if you are able to fit 6 standard deviations, 6 10.8, that technically 6 into 10.8 should be this distance. If you are able to do it either between a USL or an LSL, right, whichever is nearest to the mean point, then we call it as a Six Sigma process. And this area beyond the LSL and USL, which is supposedly the defective area, should not be, or let's try and see that, the implication of that in the next slide. So this area we are talking about should not be greater than 0.0034 percentage, right? We're talking about the entire area as 100%, and here we're talking about this area of defects should not be more than 0.034%. So when I multiply this with a million is when I get 3.4 defects when I perform 1 million transactions, right? You remember we were talking about this. So it should be either less than or equal to 3.4%. It should not be more than 3.4%. If it's more than 3.4% or 3.4 defects, right? 3.4, not 3.4%, sorry, 0.0034%. It's very important. Or 3.4 defects when I do million transactions, right? So if that is the case, then we call it as a Six Sigma project. And this is how we graphically represent that. Okay. So now let's quickly look at some examples of Six Sigma processes. So Six Sigma process, some examples if I have to take, I would take the power cuts in the US, Dabbawalas in Mumbai. They all operate at Six Sigma levels where their defect rates are really, really lesser than 3.4 defects when they do a million transactions, which is true. If I'm taking power cuts as an example, this is the level in which it should work. That means there should not be more than 9.1 seconds of power cut in a month, which has 31 days, right? So if it is lesser than that, that's a better process, which is more than Six Sigma. If it is lower than that, that means, it's higher than that, 9.1, it's 10 minutes or 4 hours, my process quality will dip, okay? So Dabbawalas is also something like that. When they make a million deliveries, they wouldn't really go wrong more than 3.4. It will be always less than 3.4. So that's one of the examples, two of the examples. You can talk about other examples. You can think about other examples maybe you are familiar with, which operates at such high levels, okay? Now let's look at some of the industries working at what levels. Okay, so airline industry, domestic industry, you see that there are no fatalities, right? There are no crashes every now and then, so that they operate at best in class or probably at Six Sigma levels or over Six Sigma levels. Whereas all these industries, doctors, prescription, airline, baggage handling, these are prone to errors. They operate at say 3 Sigma levels, right? It's middle process. And then, obviously IRS and tax, that there's a lot of complications in there. A lot of times we don't get our returns on time or probably the right returns, and then we'll have to probably revise our readings and all of those things. It's very common. So they operate less than 3 Sigma levels. Okay, so these are some industries. If we have to talk, what levels do they operate in? Okay, and benefits of using Six Sigma is very important. That when you use or deploy Six Sigma in the right way, you can expect somewhat like a 20%. This is an average number which we have seen in many industries. Okay, so margin improvements, that's your profitability improvement, or you can increase the capacity of your plant by 12 to 18%, right, by increasing productivity, or 12% reduction in employees. It's one and the same. Or sometimes you can even aim at say about 10 to 30% of capital reduction, right? For a company, it's a big deal. So some of the numbers we have gathered from the industry as a thumb rule, just to give you a flavor. If you can implement it, what kind of savings can you expect? Okay. So now let's quickly look at what is lean, right? As a methodology, lean is, so Six Sigma is a methodology we spoke about. As a methodology, it focuses on reducing the variation. But whereas in lean, the objective of lean is to create flow and to increase the velocity, the speed in which you run your process. the faster the better, right? So that's the whole objective. So how will lean make sure that it happens is by eliminating the non-value adding activities, or sometimes we call it as wastes, or in wastes, that means which are not really adding any value. We are still doing those activities. If you cut those activities, obviously the number of steps will reduce, and obviously the time taken to complete the entire process will reduce, right? So when this methodology is combined with Six Sigma, that means improving the velocity and reducing the variation, if you apply it together, is when you will talk about the method called as Lean Six Sigma. Okay, so that's the new Lean Six Sigma what we talk about today. So Lean is a different concept, methodology. Six Sigma is a different methodology, but when it is combined, you get superior results, right? So you reduce your variation and you increase the flow. Excellent. So where do we apply Lean and Six Sigma? It's a very important slide where we'll talk about 4 different combinations. So where a situation where you really don't know what's your problem, you know your problem and you very well know what is to be done to solve that problem, that won't call for a project, right? It's just do it kind of a case and activity. So you wouldn't really want Lean or Six Sigma to enter that stream. Okay. So where if a situation is that you know a problem, but you don't know the solution for how to handle that problem. Say, for instance, you know that your quality levels are low in your process, but you don't really know where exactly the problem and what you need to do to bring it up. So that means that is a problem where you need a project. If that project or the problem is related to variation, right? If it is related to variation, then we will call that problem as a Six Sigma problem, okay? And if the similar situation where you know the problem but you don't know the solution, but the problem is with the velocity or the speed of delivery, that means the customer is expecting you to deliver in 3 days time, but sometimes we do it in 4 days or 5 days, but definitely not in the range of 3 days. So that means you need to increase the velocity of the process so that you would be able to deliver it on 3 days or less than that. So if that is kind of, if the objective is to increase the velocity, that's when we will use Lean as a methodology and solve that particular business problem. And there could be a situation where you don't really know about any problems, you don't know anything about the solutions either. So that's a situation. It may not be an ideal situation, but you can probably try and use your voice of the customer or voice of the process or voice of the business and find out if there is any problem at all and see in which quadrant does it fit well. Okay. So we will talk about VOC, VOP, and VOB in the next lecture. For now, these are the 4 different dimensions you have to decide on which methodology to be used for what kind of problems. Okay. So finally, to close with Six Sigma as a methodology, we spoke about DMAC as the way to solve a business problem for an existing process. Okay. So define starts with defining the problem, right? And then measure goes against that problem by gathering evidence in terms of what are the potential reasons for this particular problem to happen, right? And you gather all your potential reasons and then obviously your problem, and then you try and analyze to statistically validate which of those high level reasons you have gathered are really the reason or the cause for your problem, right? So that's root cause analysis we do in analyze phase, and you establish a relationship between the most important reasons to the problem, right? And then finally you will freeze on that, then you will identify a solution for those problems or the root causes you've identified, how you can solve it so that you have a desired level or you control your problem and keep your process at the desired level. So that's where you will find out the solutions. In the generate solutions, improve your process by deploying the solutions. Okay, so you, after the improve phase, you may have seen or you would see your processes getting better, your performance getting better, and it started operating at the levels you want. And finally, control is all about sustaining or holding the gains. What you have improved here, you don't really want to lose it. So you have a mechanism in place to control the process, and it also clearly defines, in case if the process goes out of control, what are the 5 steps you need to take to bring it back to the control. So it's all about holding on to the gains. Whatever hard work you've done in define, measure, analyze, and improve, you don't want to lose it. It has to stay in the process for a lifetime, at least till the process is alive, right? So that's all about control phase. So I hope you understood the lecture, and I shall see you and talk to you in our next lecture with some interesting concepts on Six Sigma again. All right? Thank you so much.